Hello and welcome to Rationals 1.3, adding and subtracting rational expressions. Alright, today we're gonna pretty much learn skills that are gonna teach you how to do common denominators. The only thing is that the things that you're gonna see eventually be on the bottom of fractions are gonna be weird, like some of the things that we're gonna show you in today's lesson. So today is just pretty much the beginning to just get you ready for adding and subtracting fractions that have not so nice bottoms or denominators. Okay, so let's just go for it. All right, so there's a technique that I'm going to show you guys to make things like this match up. So you just got to imagine that what if every single one of these terms, or whatever you want to call them, are on the bottom of fractions. Yeah, so let's say there's a 1 on the top, and each one of those are on the bottom of each fraction. And your job was to find the common denominator, or you could call it LCM in this case. Yeah, it's not going to be very fun, yeah, to make them all match up, but if you have a pretty good technique that you can use, then it should be not that bad. Okay, so let's do this problem. All right, so we're going to break apart each of these bottoms, or denominators if you want to call them that. And we're not going to break them up into the typical ways that you normally saw when we did radicals. So it's going to seem like that in the beginning because I'm going to say the same things that I typically said for radicals. But when you see me writing things down, you're going to be like, oh, whoa, okay, this is not the same. Okay, so 18x squared y to the fifth. We're going to break up the 18 into 2 times 3 times 3. So here's my 2, and 3 times 3, I'm going to write it as 3 squared. So notice this is where you see your first change. Normally I write 3 times 3, I write 2 separate 3's, but I'm going to write 3 squared, so that's a little bit of a difference. Okay. Then when I break apart the x squared, I'm not going to write x and x, I'm just going to write x squared. And when I break apart well, I'm not really going to break apart the y to the fifth, I'm just going to write y to the fifth. Okay, so there's no breaking up of the letters like you typically do for radicals. Okay, all right, so let's break apart the 24 x to the third y z squared. Okay, so 24 is known as 2 times 2 times 2 times 3. So 2 to the third power. Whoa, what is that? My pen is kind of freaking out. So 2 to the third power times 3, and then x to the third, and then y, and then z squared. Okay. All right, and then the last one, 15 y to the third power z. Okay, so let's break that apart. So that's going to be 3 and 5. And notice how, you see how I'm writing everything down. I'm lining everything up where it's kind of like matching, or the columns are the same exact number or letter. Okay, so try to do that when you try to do your problems tonight as well, because then that's going to help you to understand what to do in your next step. Okay, so setting it up is going to be pretty important to ensure success, okay, in your next step. So now that we have everything all broken up into smaller pieces or separate pieces like I did, you're going to go to each column and you're going to ask this question. Okay, out of all 3 broken up terms, I guess you can call them, which one has the most of each letter or number? Okay, so let's go to the first column. Yeah, so the top guy has a single 2, the second guy has 3 2's, the third guy has no 2's. So who has the most? And whoever has the most, I'm going to circle it. So he has the most, so I'm going to circle him because he has 3 2's. Okay, so the second column, right, who has the most 3's? So we have 3 squared up top, and 3 and 3 on the second and third row, single ones. Yeah, so the top guy has the most, so I circle him. Go to the third column. The first 2 guys don't have any 5's, so therefore we're going to circle the bottom one because he wins pretty much by default. Yeah, because nobody else has 5's. All right, next column. Who has the most x's? The middle guy has the most x's. And then go to the, what is this, 1, 2, 3, 4, 5th column. So who has the most y's? The top guy does. And the last column, who has the most z's? The middle guy does. Okay, so all these red circles basically represent the most of each column. Yeah. And what's good about what I just circled is we pretty much found the LCM. So when we put all these pieces together, like the 2 to the third, the 3 squared, the 5, the x to the third, the y to the fifth, the z squared, when I put all these red circles together, they're going to represent my LCM. Okay, hard part is you got to multiply all these numbers now. So 2 to the third is 8. So 8 times 5 is 40. and 40 times 9, right? Because 3 squared is 9. Yeah, so 2 to the third is 8. 8 times 5 is 40, and 40 times 9 is 360. So 360 is going to be my number. Oops, I want to put it in blue. Wow, what are all these random lines popping up? Okay, all right, let's erase them because that's kind of distracting. Okay, so let's put it back to blue. So our number is going to be 360. And then my letters are going to be x cubed, y to the 5th, z squared. And there you go, there's your LCM. So if I had to make everybody match at a common denominator, it would be what I just wrote as the LCM on that line just now. Okay, so eventually this skill is going to pay off when you have to make everybody's denominator match, when you add or subtract fractions one day. Okay, all right, next problem. So same exact technique. We're going to break everybody up into smaller pieces. Let's put everything on the side here. So 6 m to the third, n to the 5th. Okay, so let's break this guy up. So we got a 2 and a 3, that's your 6. And then we have m to the third and n to the 5th. Okay, so next one, 42 mnp squared. Okay, so 42 is going to be a 2, a 3, and a 7. Okay, and then he also has an m, he has an n, and he has p squared. Okay, so next number, 36. Always it has a lot of letters, so 36, m to the third, n to the 4th, and p. Okay, so 36 is going to be 2 and 2, because that's 4, and 3 and 3, that's 9, right? Because 4 times 9 is 36. Okay, then m to the third, n to the 4th, and p. Okay, so I'm going to get my red pen out. I'm going to circle the most for each column. So the most for the 2's is the bottom guy. The most for the 3's is the bottom guy. The most for the 7's by default is the middle guy. The most for the m's is a tie. So since it's a tie, you can circle anybody you want. So I'm just going to circle the top guy because he hasn't won anything yet. So I'll circle the top guy because he's feeling kind of left out. Okay. Then most for the ends will be the top guy. He won twice in a row. Feeling sorry for him tonight, the competition before, but he just won twice in a row. And in the last column, middle guy wins for most P's. Okay, so when I put everything together, we got 2 and 2, that makes 4, 3 and 3, 2 and 2. 2 squared is 4, 3 squared is 9, and then 7. Okay, so I'm not going to actually kind of like this multiplication. So we got 9 times 7, that's 63. And then 63 times 4, so I'm just going to do this on the side here. So I got 12, carry the 1, 24, so 252, I believe. Hope that's correct. Hopefully I didn't make a careless error. Okay, so 252 is my number. And then m to the third power, and n to the 5th power, and p squared. Okay, so this is your LCM. And if these three things were all on the bottom of fractions, this would also be my common denominator. Okay, all right. So just keep in mind what this skill is eventually going to be used for. Okay, so now we're going to move on to different kinds of things that you're going to potentially put on the bottom. So imagine these are on the bottom. Okay, so this time we're not gonna break everybody into pieces. Okay, we only do that technique when we have problems that look like 1a and 1b. Yeah, where we don't have anything in the form of binomial, right? Binomial is when you have like things like p plus 2, p plus 3. Yeah. So if we have things that are in the form of this, like problem 2a, then we're gonna use another technique to find out the LCM, and it's basically the matching game, right? You want to have everything that everybody else has, okay? And as long as both sides have the same exact bottoms, then everybody is happy, right? So think of it as kids growing up in the same house, right? And they're always going to want what everybody else has because that's just basically how kids are, right? So if you get one kid something, you got to get the other kid the exact same thing. Otherwise, one kid's going to feel left out, yeah? So just imagine this is a family dynamic and we have to get the same thing for everybody because I guess they're pretty much like the same age, right? If they're different in age, like 10 years apart, then there's no way the older kid is going to want exactly what the younger kid gets, yeah? But if they're pretty much the same age, then yeah, they're going to want to have the same things, all right? So It's just a matter of, like I said, making sure everybody has what everybody else has. Okay, so do both sides have a p? Left side does, right? He has a regular plain old p. Right side doesn't. So let's put a p on the right side. So just like that. Okay. Do both sides have p plus 2? Nope, only the left side has p plus 2. So I got to put p plus 2 on the right side also. Okay. And the left side has a p plus 3. The right side also has a p plus 3. So he's good to go. I don't have to write it down this time. But the right side, though, has an extra p plus 3. Does the left side have that extra p plus 3? I don't think so. So the left side needs to also have the extra p plus 3. So let's just do a quick check, inventory check. Do both sides have regular p, just p by itself? Yep. Do both sides have p plus 2? Now they do. And do both sides have 2 p plus 3s? Yes, they do. Okay, so your LCM is going to be p times p plus 2 times p plus 3. And if you want to get a little, you want to shorten it up, you can just write p plus 3 squared. That's perfectly fine. Okay, or if you want to write p plus 3 twice, that's fine also. It doesn't matter. I forget what I put in the answer key on the website, so either way is fine. P plus 3 squared or p plus 3 times p plus 3. That's both. They both work. Okay. All right. Next problem. So once again, yeah, we're going to imagine that they're on the bottom of fractions. We're not going to draw that because it's going to confuse you guys later on if I keep on doing that. So I'm going to stop that. But we're just going to do the exact same thing. We're going to ask each other if everybody has what one side has. So let's go in order. Just go left to right. Does everybody have a q minus 2, both sides? Yep, left side has a q minus 2, right side has a q minus 2. Okay, does everybody have a second q minus 2? Well, left side does, but does the right side? Unfortunately not. The right side does not have a extra q minus 2. So we're going to give the right side an extra q minus 2. Okay. And now let's move on to the right side. Does everybody have a regular plain old q? Nope. Left side doesn't have that, so let's give them an extra, or not extra, but let's give them a q. And then the right side has a q minus 1. Does the left side have a q minus 1? Nope. So let's put a q minus 1 on the left side. So let's just do a quick inventory check, and let's see if everybody has the same exact matching thing. So both sides have a q, both sides have a q minus 1, and both sides have 2 q minus 2's. So when I write the LCM, I write q minus 1, and I write q minus 2 quantity squared. Okay, and you can write these in any order if you want. Okay, you can write q minus 2 squared first, and then q minus 1 after that. It doesn't really matter. Okay, as long as you have the same elements on both sides, you found your LCM. Okay, all right, so next problem. Number 3. So now we're finally getting into fractions, and we're going to start utilizing some of the skills that I taught you to make LCMs, but in this case we're going to use the LCM to become the common denominator. Okay, so let's break apart these numbers. So we got a 12, let's change it back to blue. So we got a 12, which I'm going to rewrite as 2 squared times 3. And then we have a 50, which is going to be known as 2 times 5 squared. Right? So notice how I can still write everybody in their own column. Okay. Then I'm going to get my red pen. I'm going to circle the things that are the most. Okay. So the top guy has the most 2's. The top guy has the most 3's. And the bottom guy has the most 5's. Okay. And the meaning of this basically is you just found your LCM. So your LCM is going to be 2 times 2, which is 4. 5 times 5, which is 25. And a 3. So 4 times 25 is 100. 100 times 3 is 300. So your LCM is 300. So both of your fractions need to have a 300 on the bottom. So here's the part that students don't like to do all the time, because they're thinking, how do I get a 12 to become 300? Okay, so let me show you a trick. Okay, so this trick is going to teach you how to turn a 12 into a 300. So let's look at the 3 red circles that I have up above. Okay, so let's erase the numbers that are involved in making a 12. Okay, so erase the numbers that are involved in making a 12. So I erase 3, and I erase 2 squared. Okay, so those are my numbers that are involved in making 12. Yeah? And when I do that, whatever is not erased, which is the 5 squared, that's going to be the number that I use to make 12 turn into 300. Okay, so I'm going to go and multiply 12 by 25. And the rule for fractions is if you times something on the bottom, you have to times the exact same thing on the top. So 25 also on the top. So that's how I turn the first fraction into a 300 on the bottom. Okay, all right, so let's rewrite the numbers I erased earlier. So I think this was a 2 squared, and this was a 3. Okay, and let's figure out what do I need to turn 50 into 300. So let's use that exact same technique that I just used. Well, so I'm going to erase the 5 squared because that's called 25. And I'm also going to erase one of the 2's. There's 2 2's here, but I'm going to erase one of them, right? Because 25 times 2, that's 50. And whatever is left in the red circles is going to be the number I need to use to turn 50 into 300. So a 2 and a 3 is in the circle, so that makes a 6. And that's how I turn 50. Oops, turn it back into a pen, sorry. And that's how I turn 50 into 300 times by 6. Okay? So hopefully you guys like that trick. All right, so my new fractions are 125 over 300 minus 18 over 300. And since they have the same denominator, you guys were taught back in your other math classes that you can just subtract 125 minus 18 and you get 107 over 300. And there's your final answer. Okay? All right, moving on. Number 4. Okay, so we got the same exact concept going on, right? We're going to break apart 15y squared. We're going to break apart the 18xy. And let's see what happens. So 15y squared, let's break him up first. So he's going to become 3 and 5 and y squared. Okay? And then the 18xy, we're going to break him up into 2 and 3 squared. Those are my numbers. And then a single x and a single y. And I'm going to get my red pen. I'm going to circle the most for each column. So the most 2's are on the bottom. The most 3's are on the bottom. The most 5's are on the top. The most x's are on the bottom. And the most y's are on the top. Okay? So my LCM is going to basically be so 2 times 3 squared times 5. So let's do this. 2 times 5 is 10, and 10 times 9 is 90. So LCM, let's write LCM, that would be nice. Because LCM also is known as common denominator, and x and y are my letters for my common denominator, x and y squared rather. Okay? So now the trick is we're going to have to turn 15y squared into 90xy squared, and we got to turn 18xy into 90xy squared. So we're going to do that exact same technique that I used earlier. We're going to erase what we need. Okay, so right now we're trying to make the left side into 90xy squared. So we're going to erase what it took to make 15. So let's erase what it took to make 15. So we're going to erase the 5, and we're going to erase 1, 3. So that makes it 15. And then we're going to erase the y squared. Yeah, so erase whatever you have currently. So we currently have 15y squared. So I just erased 15y squared for all my circles. And whatever is left, that's what I need to use to turn it into 90xy squared. Okay, so what's left in the red circles? I got a 6x. So that's what I'm going to put. Oops, let's use the pen. That would be nice. So 6x is what I'm going to times to both top and bottom. Okay. All right. So let's write back what I had in the circles. Let's see if I can remember. Yeah, I think this was a squared. And oops, wrong color. Let's go back to blue. That would be nice. So this was a squared, this was a 5, and this was a y squared, I hope. I'm going to forget after a while. All right, so now let's figure out what it takes to make 18xy. So let's get the eraser, and let's erase what I need to make 18. So 18 is 2 times 3 squared. So that's my 18. And then I got to erase x, And then I got to erase one of these y's. So let's circle that. Let's erase the 2. That's the power of 2. So what's left in the red circles? 5 and y are left in the red circles. So top and bottom are going to multiply by 5y. Ooh, that's the wrong color. Usually I put that in red. Let's do that. Let's change it back to red. Sorry about that. So 5y on top and bottom. All right. So, just notice this. I have to do domain restriction. Yeah. And we have to do domain restriction because we have letters on the bottom. Yeah. And because we have letters on the bottom, we're not allowed to have any of those letters turn into a 0. Because if any of those letters turn into a 0, then it's going to have a 0 on the bottom of the fraction, which means that is pretty much illegal. We're not allowed to have zeros on the bottom of fractions. And if we ever do, we better avoid those numbers because, yeah, that's going to make our problem pretty much go crazy. Okay, so we don't ever want to have the x become a 0, because if x becomes a 0, the entire bottom of the fraction turns into a 0 because they're all multiplied with that x. Okay, we also don't want to have y turn into 0 because that's going to make the bottom 0 as well. So let's avoid x equals 0 and y equals 0, because if that happens, this problem pretty much falls apart. Okay, so my brand new fractions, because I have to multiply by numbers to make the denominator match, I get 42x squared over 90 xy squared, and then plus 5y squared over 90 xy squared. So because they're the same denominator, I can turn everybody into one gigantic fraction because they have the same denominator. So I just put everybody with 90xy squared, and then I combine whatever's on the top. So luckily 42x squared and 5y squared, luckily they're not like terms, because if they were, I gotta add them up. Yeah, but luckily they're not, so I just leave them as they are, rather, or as is. Okay, so that's your final answer. Okay, all right, next problem. Okay, so this one is going to be the same exact problem as number 4. It's just going to be set up and looking a little different. Okay, so the first thing you probably want to do to make this thing look a little easier to manage is you want to put the x plus 4 in parentheses. Okay, all right. And last time I forgot to do domain restriction in one of the very first steps. This time I'm not going to do that because, yeah, you don't want to forget about domain restriction, because if you do, one of the x's that are on the bottom might disappear. And if it disappears, then you might forget about a number that you're supposed to have written as a restriction. And this is kind of like what I talked to you guys about in Rationals 1.2. Yeah, sometimes the denominator and numerator flip, like in division problems, and sometimes the x that was on the bottom is no longer there, and you forget about a number. Yeah, luckily we're just adding and subtracting, so that's not going to happen. But we still don't want to forget about doing the restrictions, so let's do that right away. Okay, so I know if I put a negative 4 in for the x on the left side fraction, it's going to create a 0, and I don't want to have that happen, so let's put negative 4 as a restricted number. Okay, and if I put a 0 in place of the x in the second fraction, that's also going to make a 0 on the bottom, and that's not wanted either. Okay, and I think that's it for numbers. All right. Okay, so now we're going to make the denominators match. Okay, and we're going to use a different technique. We're not going to do the circling the biggest thing technique, right? Because we're dealing with binomials now. Well, not really plural. We only have one binomial. The other one's just a regular old x. Yeah, but because we have binomials now, we're just going to have them all match. It's going to be like the family. Everybody wants what everybody else has. So this left side wants an x because the right side has an x, and because I give an x to the bottom, I gotta give the x to the top, so just don't forget that rule. And the right side, he doesn't have an x plus 4, so he wants an x plus 4. Right? Because like I said, you gotta make sure everybody has what everybody else has, because if somebody has something and the other person doesn't, then if this is a real family, you're gonna hear some screaming, you're gonna hear some crying, you're gonna hear some pouting, right? Because they all want to have the same thing. Otherwise, you're gonna scream unfair, unfair, unfair. Yeah. Okay, so this is what it's gonna take to make everybody match. So on the right side, in the parentheses, you're basically gonna put the brand new bottom, which is x times x plus 4. And I guess I could just write it like that. That looks kind of weird because they had parentheses already written there, but I'm just going to add in a couple more parentheses. And on the top, we're going to put what I had to put right next to the 5, which is an x, and I have to put whatever I put next to the 7, which is an x plus 4. And there you go. Okay, and you don't have to distribute this if you don't want to. If you wanted to go 7 times x and 7 times 4 and continue on, that's fine. But this problem doesn't really ask for it. It just wants you to type in, or not type in, but write in what should be in the parentheses. And that's all it calls for. If this is a regular problem like we're going to do in letter B, you would continue from here on out and see what happens. But that's not going to be what we have to do in problem 5A. Okay? All right. So 5B is pretty much exactly like 5A, except we don't just fill in the blanks. We're going to actually finish up the problem and simplify it. Okay? So let's do our restrictions. So we're going to want to avoid -1, because -1 plus 1 will make a 0, and that's bad. We also want to avoid 5, because 5 minus 5 on the bottom fraction, right? If I put a 5 right here where the x is, it'll be 5 minus 5, and that's going to be a 0. Okay? If I put a -1 right here where the x is, it's going to be -1 plus 1, and that's going to make a 0. And I want to avoid zeros on the bottom. Okay? So let's make the bottoms match. Do both sides have a 3? Nope. The right side doesn't have a 3, so I got to make sure I give 3 to top and bottom. Do both sides have x plus 1? Yep, both sides have x plus 1. And do both sides have x minus 5? No, left side does not have x minus 5, so we better give that left side x minus 5 also. Okay, so we're just going to make one big fraction because they all have the same denominator. So, oops, wrong color. I want to go back to blue. So we're going to make one big fraction with everybody's matching denominator. So we got a 3, we got an x plus 1, and we have an x minus 5. So that's everybody's matching denominator. And then we have x times x minus 5 on top, and then minus 2 times 3. Okay? All right, so let's start playing with these numbers. We're going to distribute the x times x and x times -5. So that's going to give us x squared minus 5x. And then -2 times 3, that's going to make -6. And on the bottom, we have 3 times x plus 1 and x minus 5. Okay, so normally you think you'd be done. Unfortunately, we're not. Okay, because we need to do what is called factoring, because the top can still be factored. And you're going to probably say to me later on in class, how did you know you had to factor? And I'm going to basically say, you really don't know if you can factor, but you just got to try. And if you can do it, then you do it. And if you can't do it, then you don't do it, and you're pretty much done with the problem. But we got to try. Okay, so are there two numbers that make -6 when I multiply and -5 when I add? And fortunately, the answer is yes. X minus 6 times x plus 1. Okay, -6 and +1 make -6 when you multiply. -6 and +1 make -5 when you add. So it was factorable. I didn't know if it was going to be until I tried, and when I tried, I realized, yeah, it can. So you have to do it. Okay, so then you're going to do one last round of trying to simplify your fraction. So basically, you're going to say to yourself, is there anything that matches exactly on top and bottom? And you're going to say, yes, there is. There's an x plus 1 on the top and the bottom, so I can erase it, or I can cross it out. So your final answer is going to be x minus 6 in parentheses over 3 times x minus 5. And I'm going to actually do a mistake here on purpose, because a lot of kids do this every year. And when you guys do it, I'm like, oh my goodness, that's not good. That's not good. Okay. A lot of kids are going to try to do this. They're going to cross out the 3. They're going to put a 1. They're going to cross out the 6. They're going to put a 2. Because they think they can cross out the 6 and the 3 and cancel each other out. You can't do that. Because this is not really a 6. This is an x minus 6. So because these guys are together, and that's why I kept it in the parentheses, because they're together, if you don't see an x minus 6 on the bottom, you can't cross out that 6 on the top. You can't just pick and choose what you're going to cross out. Because eventually, some kids are going to do this. They're going to cross out the x on the top, and they're going to cross out the x on the bottom, because they see x on top and bottom. But like I said, this is not an x. This is an x minus 5. So unless I see an x minus 5 on the top, hands off. Okay, so I'm going to uncross out all these things because you can't do it. Yeah, but I get kids every year. They try to get cute with crossing out stuff. They think they're doing it correctly because they see things on top and bottom that match or that can divide by each other, and they just try it, and they cannot do that. So please be super careful. Okay. So your final answer for this problem is just going to be this. This is the fully simplified form of the original version of 5b. Okay. All right. And that was the last problem. So good luck on this assignment, and I know you're probably going to have questions. So just ask me as many questions as you need in class, and yeah, I'll see you later. Good luck. Bye-bye.